All right, so yeah, so convolution. So when you're doing convolution, all right, so just run through these steps and then I'll do a question on it. Once you know what to do, it's simple enough. It's not really a hard topic to get your marks in. All right, so the first thing, what convolution is basically multiplication. It's like multiplication. All right, but instead of using the multiplication symbol like the dots, it does use the X. So you have to be careful with signals. A dot is normal multiplication, and when you see a X is convolution. So you're here still talking about that. So you have to be careful with where you're using, right? It's not multiplication, it's convolution with the symbol here. So just be careful with your terminology, right? So basically all it is, when you're convoluting two signals, you're just checking to see where the overlaps are. That is basically all you're checking to see in simple terms, right? Just chipping away all the theoretical stuff. You're checking to see the overlaps, where it overlapping. So you have two functions, one you can keep fixed, and you can do some stuff to the other one, and it literally just dragging it across from minus infinity to positive infinity, and somewhere in the time frame it will overlap, and you just go and integrate at that point. So what I mean by that is, let's say you have a xy plane, right? And this is positive infinity, and this is minus infinity, right? So let's say you have this shape here, and you want to convolute it with, sorry, this shape here. So think of it as you're physically moving this blue shape, you're literally just dragging it in this direction. So if this is 0 and it starts here, okay, it will always start here as you'll see when I show you the equation. You're just dragging it in this direction. So all here, you have no overlap. You can clearly see that it's not overlapping, right? So it's not overlapping, it's not overlapping, not overlapping, and the overlap will start when it hits right here. So when it hit right here, you will get the overlap. So if this at 1 and this also at 1, the height is 1. So when it reaches here, so it's already dotted line. So let's say you reach here. At this point, you don't have any overlap as yet, but you're going to start to overlap right now. Right? So what happening next is I have this yellow here. At this point, you have overlapping going on here. Yeah? And then as you continue to move the shape, you'll get different points. So it may come a time, depending on the area of the shape. So if this shape was the same size as this shape here, it will just come a time where they just completely over each other, right? And then afterwards, it will just start to move. So the area of overlap will just decrease over a period of time. So what you're doing is just looking at all the different intervals that they will overlap in, all the different positions of the box. In this case, the two boxes, the box you're moving, which is the blue, you're just looking to see the intervals or the pieces where they overlap on each other and you just integrate into it. All right, so think of it as you're starting from minus infinity, which is quite here. You're starting the shape from here and you're moving it in this direction. You'll have a period of time where you have no overlap just until you reach the shape. There will be no overlap. But when I reach the shape, according to the complexity of the shape, you will have different regions that overlap in, and it might have a different equation for the integration, as you will see when you do a question. But just remember, when you're doing convolution, you're dragging one shape from minus infinity to positive infinity, and you're integrating the parts where they overlap. That's what it is. That is really the understanding of it, right? So the steps, so convolution. So y of t is equal to the integral from minus infinity to positive infinity of h of tau convoluted with x at t minus tau d tau. Right? So this here and this here are functions that you will specify when you're doing the question, right? You specifying what these things are. Right? So not going to change. You can specify where it is. All right, so steps. So I'll break down the steps here. You could use these steps anytime you're doing a convolution question, just to help you know where you're at in terms of what you're trying to do. So the first thing you'll start off with, I think I will use a question to show you. So, so let's say we have a little shape here. Better to start. So let's go at 1 to 3. Right, and we have we see another shape that could be here. So you can say that -1 and -3. Right. So let's for now let this one on top here be x at t, and this one you can let it be h at t. Right, it don't matter which one you choose. So we can let this one be h at t, and this one be x at t. Right. So first things first, you choose. So now you will choose where you want it to be, unless he didn't specify what it is. Right. So with x at t, first thing you do, you let the t be tau, and this stopping right there. Nothing much happening without most of the transformations and stuff that's happening with this one here. So the first thing you do, let t be tau, so you get h at tau. Then you do a time reversal on it. All the time reversal going to do, as you remember, it'll just be h a minus tau. So it'll just end up being mirrored on the y-axis, right? Then after the time reversal, you'll end up with h a minus tau. So after you do your time reversal on it, you do a time shift. So you end up with h at t minus tau. Yeah, this equation here had a mistake in it. It's supposed to be x, and this is supposed to be h. Right. Sorry about that. Yeah. So you end up with h at t minus tau and x at tau. So remember, x at tau, when you get x at t, you just go and stop at x at tau. But for the h at t now, you let be h at tau. You do a time reversal, which is a mirror on the y-axis, and you do a time shift on it. Right? You can do all of this in one step. I'm just showing you how they break it down. Now, when you multiply those two together, that is where you end up with the y at t is the integral from minus infinity to infinity of x at tau convoluted with h at t minus tau d tau. So that's where I end up with this convolution equation there. Right? This is basically where you have to remember on all things. And the x at tau and the h at t minus tau is just the y-axis value of each function or the each overlapping function at the overlapping interval. That is all it is. So back to this analogy here, when the blue and the yellow overlap, it will have regions where they overlap, and the y-axis value for each shape will be the x at tau and the h at t minus. So we just multiply the two of them. That's all it is. So as you see, depending on the complexity of the shapes, you might have to calculate the equation, the line for one. Some of them may be horizontal, flat, so it'll be easier. Yeah. So you wouldn't bring it too complicated, because obviously if you bring it too complicated. It will pose a problem when it even the questions and stuff. Right? So let's keep in mind he wouldn't bring it too hard. We have a time, there's a time exam, right? So I look to start. By any questions in I do? What I do remember is that he will give you two functions. Nice. You pick x at t and you pick h at t. After you pick those two with h at t, you have to do a time reversal and a time shift to get h at t minus tau. When you have h at t minus tau, that is when you're going to be moving from minus infinity to positive infinity, and you're going to be overlapping with x at tau. That is all that going at different pieces. So pick, do your time shift, time reversal, then x at tau or x at t minus tau be moving, x at tau fixed at a certain point, and you just overlap it. That is all it is. All right, but any questions on it? Any questions, like any at all?
No.
All right, so I'm gonna start the question, but that is all it is. Takeaways, knowing this equation and just, okay, I'll just write these steps up. Say pick, or you can say choose. Say choose. In this case, you're choosing x at t and h at t, right? After you pick those two, you get the x at tau and the h at t minus tau, and you're moving h at t minus tau from minus infinity to positive infinity, and it does look for the overlapping regions. That is all it is, broken down in the most simplest form I could break it down. Yeah. So you're good with these simple steps here and the equation on top. But I really had enough for convolution. Yeah. So I look to start and try a question. Right. So you see any question here? Right.
Yeah, I can see the question.
Right, nice. So okay. So this was the previous midterm question. Yeah. So you notice it's 30 marks. So it weighted a lot. And it's a good bit of maths, right? The good thing is you don't need to do the integration. Remember, you're integrating, right? But you don't have to do the integration. You just put in the y-axis values and you're setting it up in the equation form, and that is it. You move on. Yeah? So you don't need to do the integration. So let me analyze this, right? So luckily for us, they gave us what x at t and h at t is. You see that? So now, since you have that, you still need to do where you need to do it x at t, right? So first thing you do, this will be h at tau, check. Then you do a time reversal, and what's going to happen in the time reversal is that the points just going to invert. So you're just going to end up with this here. Yeah, because minus 2 will become, 2 will become minus 2, and well, 0 is already at 0. Yeah, and then you do a time shift. So when you do the time shift, the points just going to end up, it just end up looking like this. So you have your y-axis, x-axis, just like you had before. And this is 0. So after you do your time shift, the points that you shifted up, it just gonna be two arbitrary points. So you're just gonna let this be t because it already adds 0. Right? And this is t minus 2. You can say t minus tau, right? Because it already adds 0. So you don't really need to do much with it. Yeah, so it doesn't use any points to get wherever you're sliding it off. So he there fixed already for you. So that is the end of, that will be h t minus tau. 'Cause I think you did shifts already. So when you go minus, you're going back. And that is what it is here. My positive and minus will be the same idea, right? So anyway, so you have this shape here. So you did a reversal, you did a shift, done. All right, the beginning is going to be t, and let's go back, t minus tau. But really and truly, you just care about this t here, right? This is the main part. You really care much about this ending piece here in the intervals, that is. And then you have this, the x of tau, which just going to be just as it is here. I'm not going to change, because that is the one that fixed. So going up to 1, going down to 3. Right, so we have our equation. So h at t minus tau and x at tau. So now we can move it. So when you're moving it now, you must know the regions in which it overlapping. So our way to do is think of u at t. So you write it, u at t. Yeah, that is where you walk, and you're literally walking in this direction. Right? But remember, you can start to walk from minus infinity. You can start to walk from quite back. Alright? So again, marks for the regions or listing the regions that overlaps in the correct form with respect to the equation, right? So the first region, so you can say region 1. So from minus infinity straight onto 0, you have no overlap. So you can just write that as t is less than, say, 0. Yeah, you have no overlap going on. None whatsoever. So from quite out here, straight up until right here, they have no overlapping going on. You could pi equal to. Yeah, pi equal to. Because at 0, you don't really have anything. You still have no overlapping at 0. Right? So you could use less than or equal to for this one. Right? And then from there now, you do the normal equation. So y at t will equal to the integral from minus infinity. And this one is going from minus infinity to 0. That is the interval that you're integrating across, right? So you're stopping at 0. Yeah, because you're going from minus infinity to 0. And with that now, both of them is 0. So the integral would just be 0. So h at t minus tau, all of it will just be 0. So no overlap. You could just put no overlap if you want to, but you could just go along. So it have no overlap. So the convolution will be 0. So I region 1. So right now on the shape, let's redraw the shape now. Just to keep in touch as to where we are. So remember the area, sorry, the bottom, the width of the shape is 2. Yeah, remember that, right? That's actually important. So yeah, you will know which shape when you're directly on top of each other, if it will be inside of one or if it literally just the same area or if one bigger than the other one. So just remember it's 2. So right now, this is where we are. So you write, check up underneath it. Use the orange. Okay, you just moved it from minus infinity right up to here. So as t, remember u are t, from minus infinity up to 0, it no overlap. So there's t minus 2 here now. Right? And now we're going to sort of move it into, remember you are here, you're now walking in to a region of overlap. Right? So when it start to overlap, you just have to observe the line, whatever line it is, a straight line, a curve, a horizontal line, you're looking at that line and you need to get an equation to represent the points on that line. If it's like this, where it's just a straight line, that easy because it'll just be one straight through. But for this green line here is a problem, right? So if we were to move the shape now, you end up with this. So now you're moving into here now. So you're having this going on. Yeah, so you're seeing how we have overlapping. So you are T. So the trick is just look at T. Don't worry about the back for now. So look at T. So when T here, I'm going to draw it in dotted lines. T here, same thing again, overlap. T here, overlap. And as T continue to go on and on and on, you will get overlap in the shape straight through, right up until here. Yeah, and then as you continue, you will still end up with overlapping. You will still end up with overlapping. So let's go to the regions. Just remember to look at the areas where it overlapping. That is where you always was considered. All right, so let's run through this one. So where we at now? So t is less than or equal to 0. So when t passes 0, so if t here, you have this equation, this line here. So let's try to calculate it. So, so the two things you need to calculate the equation of a line are the gradient and the y-intercept, which we already have. So c is 1, and the gradients, so the change in y, so if you say y2, so let this be y2, we know it will be minus, so 1 minus 3 divided by, that will be 0 and 1. So, what? No, I was doing the correct thing. So y1, the x is 0 and the y is 1. And this one here, the x is 3 and the y is 0. So y2 minus y1 divided by x2, subtract x1. So you end up with minus 1 and 3. I was doing the correct thing. And y will equal to mx and plus c, right? That is it. So remember, anytime you have to get the equation of any straight line, the two things you need are the y-intercept and the gradients, right? The other way in which you could calculate the equation of the line, or the other two that you need, and you're probably familiar with it, is a point on the line and the y and the gradients. Any point on the line and the gradients. So you just end up using y2 minus y1 is equal y2 minus y1 is equal to mx minus x1. So it'll be y, yeah, yeah, mx minus x1. And you just plug in your points, which is x1 on y1, and the gradients, and you just make y the subject of the formula, and you could also use this to get the equation of a line. So it's y minus y1 is equal to mx minus x1. That is if you have a point on the line and the gradients. And in this case now, since we can clearly see what the y-intercept was, which is 1, and we can clearly get the gradient, we just plug it straight into the form y is equal to mx plus c. Yeah, so there's two ways you could get the equation of that. But anyway, so our equation in line is minus 1 to x plus 1. So let's keep that in mind. So back to the convolution. This t that we have here, right? So when t just passes, so when t here, right? Remember the area, the shape is 2. So yeah, that's why it's important to know. It's not the area, the width of the shape is 2. So therefore, at this point here, if it's half half, this here will be 2 to be t here, and this here will be t minus 2. But since the area or the width, sorry, the shape is 2, they could say this here and this here is kind of half. So this technically on the green line will be the same as 1, but this here is 2. But the rectangle is 2. You have to remember that. So right now we're kind of half. So I add 1 here, and let's have 1 on this side. So see technically at 1. Yeah, so now the region of overlap that I'll be having will be this piece here from 0 to 1. That is where my overlap will be. right? Just for this shape, so 0 to 1, you have overlapping. Like it says 0 to t, right? So that'll be the next piece. So that'll be region 2. And this would be when, so this would be when t is less than 1, but more than or equal to 0, right? Like you say more than 0, not equal to. But we use the equal to in the last one. So it's already covered. So that is where t is now. It's more than 0, but less than 1, right? So same thing. So y at t, integral minus infinity to infinity, and x at tau is the equation of the line, which you already get. So it'll be minus 1 and 3 x plus 1. And then you have, well, 1. Kind of redundant to put 1 about small thing. Right? So now we have to edit this now because we know it's not going from minus infinity to infinity anymore. So we know the area of overlap starting from 0. Because we overlap. You have no overlap in here. So it's starting from 0 and ending at t. So it'll be 1. Right? And that is the second region of overlap when it's just half half because the width is 2. Right? So now when this moves now, the next logical piece will be when it's completely inside the shape. So since the width is 2, right, you could have a point where the yellow is like this. And let's erase the points on top. So the yellow would just be here, going across, and coming down like here. So this will be a t, and this will be a t minus 2. So you can have that. So that's another region of overlapping, right? So that will be at 2. So from 2 to 0, that will be a next area of overlap, right? So you could say for that one, region 3. So t, so t is less than, say, less than 3. Because remember, it already passed. So once it passed, you're inside. You don't have to worry about the back piece anymore. So you could just say t is less than 3. That'll be the next region, logically. So while t, so this time the integral is from 0 straight up to 3. Because remember, once the t minus 2 at 0, anything afterwards from 0 to 3, once it's inside that shift, inside the triangle, it will be good because you have overlapping through that entire thing. Right? So x of tau will be the equation that we had before. And the h at t minus tau just stay as 1 d tau. Right? And then now we're still gonna move. So we're just gonna end up with the opposite of what we had before. So now when t moves past 3, so 3t here now. But what happens is when t pass, you might have still have a little piece that's gonna be here. Remember the width is 2. Right? So 2, 3, this could be like 4. So they keep all those things in mind. So now your next region of overlap will be this little piece here. Right? So now the next region will be region 4. Will be when t is more than or equal to 3. That'll be the next region. Right? If you want to, you could put the n, it could be t minus 2 is less than 3. But you really need to, because understood. You really care about t. Right? So then the regional overlap would be from 2 up to 3. But that'll be the only piece that you get overlapping in. Right? Once you remember that is the overlapping you care about, that is all you're worrying about. So it'll be y at t. So yeah, this one going from 2 up to 3. Same equation line. Um, x tau is still 1, d tau. Yeah. And then you look and see what else we got. So now the next piece that will happen is when the shape completely passes. So basically, A ended up with this, you know. So now we have no overlapping anymore, right? So now that'll be a last region. So region 5. So now T is more than the 3. You could say, because we at infinity, you could just say T is less than positive infinity, and you could add in the T minus 2, and T minus 2 is more than 3. Yeah, okay, care about the back piece. Okay, we really not have any overlapping when the back piece crosses, right? Same idea, same equation. You don't really have to play in anything. Okay, I kind of redundant, so I wouldn't really do about that. So if I want to take a put it here, so it'll be 3 to positive infinity, because that would the region will be 0 for the overlapping, detail, just no overlap. You can redundant playing it, so you can just put no overlap, and that's it. Right, this question, all it is, all you care about is the overlaps. You care about the overlaps, the different types of combinations you could get for the overlap. So let me just run through the one there. So the first one, you can just have to see it, right? The first piece, this here, and he outside here, right? So remember, you're moving from minus infinity. So all this right up until here, you have nothing, no overlap. Second now, when this reach here, so the dotted line means that where it end up. When I reach there, there's 0. The next region now is when he start to chip in, when T that is, started chip in over until here. But the thing is, you have to remember that when T chipping in on this side, you still have a little piece at the back. Yeah, so if T here, that is your next region, half half. So you end up with this going on here now. So remember the shape here going from 0 to 3, 1. So this is like 1, 2, and 3. So you have, when it's half half, you basically have this going on here. Look at it. You have that. But the regional overlap they care about to be this piece right here. So, and that will be from 0 to 1. That is why I integrate from 0 to 1 just now. Because that was the regional overlap for that piece alone. Right? And then now as you continue to slide it, right? So you're now changing. So now you kind of care about the back piece now. Because the back piece now will determine when you pass the 0. So now the third region is when the back piece catch up. So you just end up having, like, gonna use more space on this side now. So you have this still 3, 2, and 1, and you have 1 here. So next one will be when it's right inside the shape. So when t minus 2 reach here, it will be like this. So it kind of inside of the shape, right? But at this region here, right, your t inside the shape. Yeah, so it literally just gonna be everything inside here. So it'll be an integral from 0 to 2. Yeah, that'll be the integral for this piece here. That when it completely inside. So at this case, your t is still less than 3, but your t minus tau is more than or equal to 0. That is where the pieces is. Remember, there's t minus tau. Sorry, 2. And afterwards, yeah, that's the opposite of what you had before with the half half. You end up with this piece going on here. So t gone and t minus 2 still lagging. So you still have a little overlapping going on here. The overlapping is just basically if you draw a straight line, if you have 2 points on top of each other, that is the overlap. You just multiplying those two. That's basically what convolution is. If it's not, it's like this piece here, it just have one, it don't have any overlap. I think hopefully that clear enough. Right? So, and the last piece, or the last region will be when it completely pass the shape. So when it starting from right here, I already no non-overlapping will start. Right? So in this case, t is less than or equal to positive infinity, and the t minus 2 is more than, in this case, it'll be more than 3. Okay? And basically, as how it does convolute here, just moving the shape across and you're checking all possible combinations of the overlaps. Remember, you just care about the region in which it overlaps. You really care about anything else, really. Yeah? So, any question then? So you get 5 by 6. Anything whatsoever. Right. No problem. So, right. So we try this one. So question, you all did um block diagram. So you showed you all the laws and stuff already. Okay. Okay. All right. Right. So I run through this. Okay. So we have this block diagram. So remember when you're doing that block diagram, we're trying to get the outputs over inputs. Right. So there's your transfer function. Right. So when you're doing this, you're trying to get or reduce the entire block diagram to a form in which you could just get the equivalent function of it. Right. So something to remember, you have a feedback, say positive, feedback and negative feedback, right? So the equation for positive feedback, so will look something like this. And then we'll have h of 1. Right, so that is positive feedback. How you know that? Because two signs here positive. We're coming back, going into a positive. Right, so the equation for that is just g1 and 1 plus h1 g1. Right. And the negative feedback is just the negative of this one. So it'll be the opposites. Right. So the negative is positive here, and the po- positive is negative at the bottom in the denominator. That's probably the only thing I remember. Right. So now we have to reduce the circuits into a form in which we could get the answers from. Right. So in this case, you just analyze the circuits and you're trying to get these patterns. And because once you see this pattern, you can just use the equation to get it. So nowhere in here we could do that so easily, right? We can't do it with this here because this prevents us from doing it. So but what we could do, we could manipulate the circuit in order to get what we want in it, right? And obviously they gave us a hint here. We can move these two to before because that would just open up the entire circuit for us, right? So if you also move, sure. So if you also cut this bar and cut this and move it across, let's draw higher, right? So you're kind of moving it outside. So this one here, you move it here, and then the one here, you just move it to the same place. Right, but when you're moving it now, you have to remember you have to keep the value that it had before. Okay, you can't just move it and keep it. Yeah, because you'll get the question wrong. So you have to take out what you're adding after. So right here, it have no G3 as yet. But when you put it after, it will have the G3 in it. So you have to cancel back the G3. So what you're gonna do is in the branch, you're just gonna add 1 and G3 in it. So when you move them, you add a 1 and G3 and put it in. It should be here. And then for this one here, same thing. You add a 1 and G3 and put it in. Right. So now all this clear. So it gone now. So with that said, since that gone, the next thing we'll do is this piece here, because now be free, right? And since going back a positive here and going back to a negative, it'll be a negative feedback loop. So you'll end up using the one with the plus, right? So you can label this A if you want to. So A, this entire thing which will just reduce to one block in the circuit. It will be G3 on 1 plus H3, sorry, my H3, G3. So that's what this piece will break down to in one block, right? And then when you break this down to get into one block, I'm just redraw the circuits. G2, now that whole thing there boiling down to this big thing here, so it'll be G3. 1 plus H3G3. You have Y coming here. Then you have the H. So since all these in series at the bottom, the H2 and this, you could bring it together and multiply it out. And the same thing for the bottom, please. So that'll be H1 and G3. Right. So since we have this now, you clearly see that kind of open up for us in the end. So you just end up with this here, which is a negative feedback loop. So since these two in series, you can multiply the two of them. So you end up with G2, G3, right? And you just do the equation that I was doing before. So that one will just end up being G2, G3 on 1 plus H3, G3, all divided by 1 plus G2, G3, and 1 plus H3, G3, multiplied by H2 and G3. All right, so that's that big block in the middle there. So I could just erase this, all this gone. Now we just have big block here, D2, D3, 1 plus H3, G3, divided by 1 plus D2, G3 on 1 plus H2, G3 multiplied by H2, G3. Right, and now it has repeat the same thing again, but now it has end up with one big negative feedback loop. So, and then that'll be a final answer. So y and x. So these two in series. So yeah, to multiply it out. So multiply by this. Right. And divided by 1 plus and the product of those two. Right. I'll just space out, that's write 8, right? So G1, G2, G3 on 1 plus H3, G3, all divided by 1 plus G2, G3, 1 plus H3, G3, H2 on G3. At the top piece, then it's already 1 piece. It's kind of understood. And then multiplied by H1, G3. Right? Yeah, so it's a long question, massive. But the simplification is just comes from repeating the negative feedback and the positive feedback over and over. Yeah, so it could get kind of cumbersome with the values, but they do very correctly. All right, so analyze it. All right, so we shall speak.